All right, today we're going to talk more about quadratic functions in section 8.2. Let's put our name and date at the top of the paper so that you can always keep track of your information. Today we're going to be looking specifically at the standard form of a quadratic function. And this is the standard form of the function where f of x is our function, a function of x equals a times x squared plus b times x plus c. All right? So whenever you're asked to put a function in standard form, that is the setup that you are being asked for. So if we find that this first term, ax squared, specifically, we're looking that this is positive. Right here, this is a positive term. Whatever numbers in front of x squared is positive, then what we see is that our parabola is going to open upward. So that is going to look like a U. Or you can say it's a positive day, so I smile. Ta-da! So here, the difference next to that is that my a, whatever the term is for x squared, is negative. That's what's being addressed here. So if my a squared term is negative, that means the parabola will open downward. And you could say that he was having negative feelings, a negative day, so he was sad. And that might help you to remember it. All right, so in our first problem, we are asked to find the equation of the axis of symmetry. We did that in the previous lesson, so that is not new. We are also asked to find the vertex of the graph of the function. And we are also finally going to graph the function and find the y-intercept. So we have 4 things that need to happen for this problem. So in getting started, we address that yes, this is already in the standard form, and we need to know the actual values of a, b, and c. So let's write them out. A is going to equal something, b is going to equal something, and c will also equal something else. So a is the term, the number in front of your x squared. It's a coefficient. And remember, if there is not a number showing, that number is a 1. So a is 1. B is this value here in front of the x. That is negative 6. Make sure you take the negative with the 6. Whatever this is, you use it. And then c is this last piece. It is a positive 2. You don't need the plus sign. It is assumed, it is understood that it is positive if you don't state anything other than that. So let's go find the axis of symmetry first. It just lends itself to be a little bit easier to find than the vertex first. So the axis of symmetry, we discussed it very briefly in the previous lesson, can be found as an equation of x equals negative b divided by 2 times a. So we say, all right, negative from my setup, b has a value of negative 6. All divided by 2 times our value of a, which we learned is 1. Okay, so now we can tidy this up and say, oh yes, I remember, let's get a different color, that a negative and a negative side by side, that makes a positive 6. And 2 times 1 is 2. So to finish this out, 6 divided by 2 is 3. So the axis of symmetry for this quadratic is going to be x equals 3. All right. We remember from our previous lesson that the axis of symmetry always goes straight through the vertex of a quadratic, which means that I can plug this value of 3 into my original function wherever I have an x, and as a result, find out what the y value will be at my vertex. So let's do that. F of 3 I got from my axis of symmetry, or 3 squared, always use parentheses when you are inserting a value into a function, minus 6 times 3 plus 2. From here, if you're not awake yet, or it's already been a long day, turn on your calculator. Let's go to a new document, never save. And we're going to use just the calculator application. And we can put in, starting from immediately after my equal sign, and we'll use the parentheses, 3 squared minus 6 times 3, close parentheses again, plus 2. Push enter, and I find that I have a value of negative 7. So f of 3 equals negative 7, and as a result, my vertex is at the coordinate point of 3, negative 7. Great, that was pretty easy to do. All right, so let's go put this into our graphing calculator. We'll put the function in the calculator, and then we can find our table. We will graph it here on our coordinate plane, and then determine our domain and range. So let's push Control Doc, and ask for a new page with a graph on it. And let's type in our original function that they gave us, x squared minus, make sure that's a minus and not a negative sign, 6x plus 2, and push enter. Okay, there is my parabola. Ta-da! And we can see that our vertex agrees with what we had found on the paper of 3 and negative 7. So now let's go find a table and look at what points we can plot. Control T. Here is 3, negative 7. And let's build a couple of points around it for the table that we write. So we have, say, 1, negative 3, 2, negative 6, 3, negative 7, that's our vertex, and 4, negative 6. And just for the sake of symmetry, let's continue with 5, negative 3. All right, let's go plot these points. That's going to be a tight graph to see. All right, so my first point is going to be to the right 1 unit and down 3 units from your central origin. 1, 2, 3. Here's my point. My second point is going to be to the right 2 units and down 6 units from the central origin. So 2, 6, so there's 3, 4, 5, 6. Third point is 3, negative 7. 4, negative 6, so now we're coming back up. And 5, negative 3. And there we are. Very nice parabola. Remember, we always draw arrows at the top of our parabola to remind us that it keeps going and going and going. It never stops. Finally, let's look at our domain and range. The domain, remember, these are your x's used. And in this graph, if we continued going, this would get wider and wider. So it will travel all the way to the left, and it will travel all the way to the right on the curve, which means all of our numbers got used. So we can write that. We'll say all real numbers. That's our domain. Its symbol is a fancy double-barred R. The range, last but not least, the range wants to know the vertical distance that our parabola travels. So your range is always going to be a relationship between the y's used such that y has a relationship with the height of the vertex. So my vertex height was at negative 7. The question is my inequality symbol going to go up and be a greater than, or is it going to go down with a less than? So my curve pointed up. So my curve is above negative 7. So all of my y is greater than or equal to negative 7. That's how you remember to use that symbol. So we can even make a note very quickly down at the bottom stating that. If your curve points up, it will be y greater than or equal to some number. And if your curve opens down, if it points down, that means y will be less than or equal to some number that we get from your vertex.